In section 4.2, we're going to study the mean value theorem. The mean value theorem works for only the following situations. First of all, my function has to be continuous. It has to be closed, which is similar to the extreme value theorem, but it also has to be differentiable at every point in its interior, which means there cannot be any sharp corners, cusps, or jumps. Okay? And basically, here's what the mean value theorem says, that if I have a smooth curve like this red curve here, and it's on a closed interval, if I was to find the slope of the secant line joining the endpoints AB, there's going to be some point between A and B that I can draw a tangent line that will equal the slope of the secant line. So notice these two tangent lines here are the same slope. So again, to find the secant line slope, I use my average rate change formula, and to find the slope of the tangent line, I take the derivative. So question 1 is saying find the value of x that satisfies the mean value theorem. So first of all, I'm looking for this x coordinate right here on this graph where the slope of the tangent line equals the slope of the secant line. So the first thing I need to do is I need to find the derivative. So the derivative is 2x minus 5. And my formula says that the derivative has to equal the average rate change. So in this particular case, my derivative was 2x minus 5 has to equal the function at b, which is the function at 3, minus the function at -1, all over 3 minus -1. So 2x minus 5, I'm going to plug 3 into my function. And if I plug 3 into my function, I'm going to just do this in my head. 3 squared is 9. 9 and 7 is 16. -5 times 3 is -15. So this is going to end up being 1. Subtract. If I plug a -1 into my function, I get -1 squared is 1. That's going to be 5 and 12. 7 is going to be 13. So this ends up being 13 all over +4. And if I work out the right-hand side, 1 minus 13 is -12 over 4 is going to be -3. And therefore, I can add 5 to the other side to get 2. And therefore, the x value that satisfies the mean value theorem is when x is equal to 1. So that means my green line's tangent line is drawn at 1. The slope of the tangent line will equal the slope of the secant line. Now sometimes, this one worked out quite nicely algebraically, sometimes we need to use technology to help us solve these. So for example, in our next example, we have my function. And again, if I want to calculate the derivative first of all, so I have 3x squared minus 12x plus 9. Whoops. So that's going to be my derivative. And now I'm going to apply the mean value theorem, which says the derivative is equal to the function. The right endpoint is 4. The left endpoint is 0 over 4 minus 0. So my derivative, 3x squared minus 12x plus 9 equals the function evaluated at 4. So if I plug 4 into my function, it's going to be 4 cubed minus 6 times 16, because 4 squared is 16, plus 9 times 4 is 36, plus 2. This is going to equal 6, so I'm just plugging 4 in here and working it out. If I plug a 0 in, I'm going to get 2, so it's going to be minus 2, and this is all over 4. So the right-hand side works out being 6 minus 2 is 4 over 4 is 1, so I'm left with 3x squared and 3x squared minus 12x plus 9. So now it's a quadratic equation. And if I set that equal to 0, I end up getting that. So now I have a quadratic equation that I have to solve, and there's a number of ways we could do it. Number one, we could use the quadratic formula, okay, or we could use technology. Okay, so let's take this equation and let's use our graphing calculator. And there's a couple of ways we could do this. Number one, we could graph this function. Okay, so I need to go to the graph setting. And my equation again was 3x squared minus 12x plus 8. So I'm going to type in 3 x squared minus 12x plus 8. And if I solve that, there's x-intercepts are going to be my solutions. So to find an x-intercept using the graphing calculator, I am going to go analyze graph. And I'm looking for the zeros. So again, I'm taking my calculator to the left of the 0, to the right of the 0. So there's my first solution, 0.845. So we should probably write that down as my first solution. So x is going to equal, whoops, x equals 0.845. And to figure out the second solution, I'm going to do the same thing for the other x-intercepts. So menu, I'm going to go analyze graph, 0, and again, lower bound, upper bound. So this one's answer is 3.15. Okay, so that would be my second solution. X equals 3.15. And those would be the two places where the slope of the tangent line equals the slope of the secant line. Now there's other ways we can do this on a graphing calculator. We could use a solve feature as well, but we'll just do the graphing feature right now, and we'll use a solve feature a little later on in the course. Okay, and the last example, this one's a little bit more challenging because we have this e involved. So to find the derivative, first of all, I have to use the product rule. So it's going to be x squared times the derivative of e to the x, which is e to the x, plus the second function, which is e to the x times the derivative of the first. And again, if you factored out an e to the x, you're going to get x squared plus 2x. So there's my derivative. And again, we want to find the values that satisfy the mean value theorem. So we want to figure out where does the derivative equal the average rate change. Okay, so the derivative was e to the x, x squared plus 2x equals, well, f of 1, if I plug a 1 in here, I'm just going to get e, subtract negative 5 squared is going to be 25, and that's going to be e to the negative 5, and this is all divided by 6. So now I'm going to come up with the value of that on the right-hand side. So if I was to go to my calculator and type in e to the first minus 25 e raised to the negative 5, that would be 2.549 divided by 6, and approximately this is going to be 0.42497, and that's going to equal e to the x times x squared plus 2x. Now, this is a very complicated equation to solve, so again, I'm going to use the graphing feature. What I'm going to do is I'm going to graph the left side of this equation as one function, the right side is another, and I'm going to find the intersection point. So I'm just going to clear out my old graphs, and now I'm going to enter in the new ones. So my left equation was e to the x times x squared plus 2x. So it's going to be e to the x times x squared plus 2x. And if I enter that graph, it looks like this. And then my second one is just a constant, and that constant was 0.42497. So it's 0.42497, which is going to be a horizontal line. And my solution now is going to be the intersection point. So again, to do the intersection point, I go menu. I want to analyze the graph. I want to find number 4, an intersection point. Again, I move my cursor to the left of the intersection point, then to the right. And my solution is the x-coordinate right there, which is 0.166. So the answer to this problem is going to be when x is equal to 0.166. And that would be my final answer. Okay. Now, an application of the mean value theorem is Rolle's theorem, and Rolle's theorem is just a special case of the mean value theorem, and basically it says again that my function has to be continuous, closed, and differentiable, and it's basically saying if the values of the endpoints are equal, then there's at least one place where the derivative is 0, and if we think about that from the formula, if I have my mean value theorem, which is f prime equals f of b minus f of a over b minus a, and if these two things are equal and I'm subtracting them, this is going to be 0. So that means the derivative has to equal 0. So below it says, given the function, show that Rolle's theorem applies and find all values that satisfy the Rolle's theorem. So first of all, I must show that f of -4, if I put -4 into my function, I end up getting -5. And if I put 0 into my function, I also get -5. So since the values of the endpoints are equal, therefore Rolle's theorem applies. So that means there must be a place where the derivative, and the derivative is 2x plus 4, must be a place where the derivative equals 0. If I was to solve this, I would subtract 4 and divide by 2. Now to get x being -2, -2 fits in that interval, so that's the place that satisfies Rolle's theorem. Okay, I do have a handout for you to try, and the handout includes a few questions going all the way from A to C and also from 1 to 7. So I'm going to let you try those on your own, okay? And then there's also a few other questions that are in other handouts, so I'll give those to you in class. So that basically concludes section 4.2, the first part of the mean value theorem and Rolle's theorem.